Welcome to Exposure. My name is Alex Spivakovsky and I'm the head of research at Pentera, and I'm super excited to be here together with you in this virtual event. When I was first approached to speak on this convention, the opportunity appealed to me because of the wide range and array of cyber experts and leaders that shared together with me this virtual stage. Today I will be talking with you about how you can use automation in order to improve your web application validation, and basically use automation in order to hack and find breaches in your web application. A few words about myself, the head of research at Pentera, the best job of my life. Basically, we are researching and consolidating all techniques and discovering new techniques in order to improve the validation of your security controls and application and systems using automation. Prior joining Pentera, I had several positions that range from penetration testing to group management of incident response experts in the Israeli Defense Forces. Every problem-solving algorithm starts with modeling of a reality. So we have the reality. We know that things can improve in the reality. Before we dive into and create a model, create an algorithm to solve the problem, we need to modelize it, to create some basic structures that we can later automate and build mathematical algorithms in order to solve it. If I take hacking, general hacking, not necessarily a web application, then the first thing in hacking is to learn how can you interact with the system that you want eventually to compromise. Okay, so first thing, we need to discover interaction points. Once we discover interaction points, we need to start interacting with them, sending them messages, and treat each response as an attack propagating asset. Each bit of information is important because later on, when the story progresses, we can use it in order to enhance and to create more attack scenarios. For example, when you have your SMB open, you will try to enumerate shares. And by enumerating shares, you will know, okay, in those folders, maybe I have data. Some folders, I have write access, so I can manipulate data. Maybe this can propagate my attack. With WMI, you can execute code, you can query stuff about the operating system, and then you can learn stuff about users and other networks. LDAP, you can create bloodhound queries where you understand the organizational structure of the domain. And we will take this and apply this to web hacking. Web hacking, when you hack a web application is not different than SMB. SMB is a service that runs on top of the operating system that was built by Microsoft coders. Web applications run on top of the operating system that runs a web server. It runs on top of the web server, and it also was built by coders. Bad coding practices, misconfiguration, bad implementation, problems in deployment can create a breach. A breach in a web application can range from a data leak to a full compromise of the operating system on which it runs. An interest in web application arose because of the fact that this is one of the most common interfaces in network system. It ranges from internal organizational applications like user management, salaries, reporting of hours. It can go to management interfaces of your network gear, ESXi's, etc. External facing, again, maybe some management interfaces like your firewall or routers, websites. Web application is one of the most common accessible interfaces that exists. This is why we had to put an effort into understand how we can validate it, and our tool is automation. It is also well known that web servers are targeted by hackers across many verticals, and in sectors like retail and government, this is one of the main entry points. So let's talk about how we can automate the discovery of assets assets, I remind you, is bits of information, and how we can propagate the attack using those assets. Disclaimer, my personal belief, and I stand by it. Automation will never replace an experienced web penetration tester, but it can improve greatly its effectiveness by creating a streamline of not just information, but knowledge. Good model of automation and good assets generation can create a streamline of knowledge to the penetration tester, and so it will improve its performance. Proposed approach, very simple. First, we need to discover and map the web routes in an application. Web routes, paths, types of requests, and parameters. Derive attackable assets. Each attackable asset can propagate the attack. Each attack propagation, basically execution of attack, can lead to more information disclosure. Each information disclosure can generate more assets. This is why the process of attack automation is not a playbook. It's a real thing. It's attack. It's something that is continuous, because every new attack phase generates more information to the attack navigation calculator. Web route discovery. So the attacker will try to hack the web app, and we will set up a proxy server. The proxy server is there for request interception. We will create an automation which will start crawling inside the web app. Each request to the web app gives us an HTML page, and each HTML page contains links, forms, JavaScript files and JavaScripts that can create dynamic requests, asynchronous requests. All of those are transmitted into the proxy server, and the proxy server says, okay, so I have a request to this path, I have a post request to that path with those parameters, and so on. Great, we have an initial list of routes. We will take each and every one of those routes and request them from the web app. New request, new page will be shifted into the proxy server, and the proxy server will collect more requests and more possible web routes. We will iterate on each and every one of those routes recursively until full exhaustion. And my recommendation is don't leave the boundaries and the boundaries of your web domain, because the process won't finish. You know, if you have a link to google.something, don't reach out and ignore it. Stay only within the scope of the web domain that you're trying to research. Okay. Before we reach exhaustion and we have a nice list of web routes, my suggestion also, let's collect more routes by doing dictionary-based attacks on the collected routes. For example, if I have path, I will also append admin.php, administration.aspx, maybe add some more common paths that may exist, because when we crawl pages, not every possible route eventually will appear there. So we will also do another phase of guessing web routes by adding and entering some logical possible routes. So maybe we will send 1,000 more requests. We will find out some more, and eventually we have a collection of a nice set of web routes. Okay, now it's the time to take all those discover routes and derive attack assets. And because this is the first time that we're doing it, okay, this will generate the first phase of attack assets. So, for example, given each and every route, I will send it to the asset analyzer. The route generates a page, and for example, I can extract forms. Forms are an attack asset because forms are a mean for me to interact and to send commands to the web server, because usually forms collect information, text, dates, emails, and they're sent to the server for processing. each interaction with the server, basically it's an entry point, a possible entry point for the hacker, an interaction point, as I said before. So we can extract the forms from a web page using Beautiful Soup, for example, or any piece of library that you would like, but eventually this is free text parsing. Supporting technologies. Usually in web application, we will use libraries that are commonly used in the community, like WordPress, for example. And knowing the type of technologies that support the web application is a great asset for the attacker, because if he's familiar with the vulnerability in, for example, WordPress, he can use it and leverage it to get access to the web application, maybe bypassing it and reaching to the operating system eventually. Error pages. Error pages are a great interaction point for a hacker. It can disclose a lot of interesting information. And the way to derive it is basically reach out to an endpoint. If for some reason you get an error code from the 500 family, treat it as an asset. And I will show you in a few slides how this can benefit an attacker. Login pages. Login pages are a specific subfamily of forms, and I will explain also why this is a great asset. Administration pages of PHP, of IIS, they're great for an attacker, and all of this is collected using automation. So instead of the penetration tester, validator, to look for those bits of information by himself, the automation using transmission to the proxy, and the proxy generates the possible web routes, and using simple automation scripts you can that derives those type of assets. This can save, from my experience, this can save hours and hours of work for the penetration tester. And imagine that the penetration tester starts its workday with those data in front of his eyes, and much more effective. So let me elaborate. So let's talk about, for the example, the attack propagation phase, and take several examples from before what I've mentioned. So supporting technologies, we are using a Wapalizer. You're familiar with it. If not, great plugin. Basically, it's a plugin that when you reach out to a web page, it renders links, meta tags, and other tags in the HTML page, and derives what kind of supporting technologies are used. And I mentioned before that you can reach out to a page and understand that the supporting technology is WordPress. WordPress is a great content management system, but due to the fact that this is a modular platform, you can integrate plugins that the community writes. In some plugins, and if there is bad implementation in the plugin or in the installation of the plugin, then it can create a breach. And a breach in WordPress will basically hold for every web app that uses this technology in that plugin. So using automation, I'm asking from my agent, from my engine, please give me all the discovered WordPress assets. Okay. It delivers all the WordPress assets that we found prior using automation, using the database of the Wapalizer. And now I can query all the websites and all the pages, all the websites that are WordPress, and say, okay, so give me the XML RPC PHP page. And this page, when it's requested, if for some reason one of the web pages returns an error code 405, then I know that it has the XML RPC interface open, and this is a major entry point. This is a more significant asset for the attacker in order to take control over the web application. For example, the fact that this top website returned me the error code of 405, I understand that, okay, this website is vulnerable. So using discovery of routes, an easy way of determining if a website is WordPress, and transmission of one GET request, I'm able to trim down the vulnerable WordPress websites that exist in my network. Great. I mentioned before login pages. A login page, it's an opportunity to test for common passwords, password reuse, brute force attempts. So when I will ask for my automation engine, can you give me all the forms that basically are all the forms? In order to deduce that a form is a login form, we will just iterate on the forms. We will extract input button select tags, because usually sometimes you don't just enter username and password. There are more fields that are need to be added. If you detect the CSRF token, this is another lead for understanding that the form is a login page, and it's very easy to understand that the field is CSRF. Basically, look at the default value. If it's a hexadecimal string, you got it. It's a CSRF token field. Detect password field, easy, the type of password, and username field detection also is very easy to understand, because you usually will have the name of username, user, login, etc. Once we understood that the page, that the form is a login page, it's a login form, now we know that, okay, we need to generate a post or get request with to the specific route, where the CSRF token remains the same. We don't change it, and we play with the username and password fields and send it off to the server. And this enables us to create a validation if usernames and passwords are common, maybe there is a reuse, maybe it's prone to a brute force attack. This is also a great way to validate if the web app is connected to your LDAP server. This is also a great mean of testing if this connection really works. I mentioned before error pages. Error pages are great because first, it generates a lot of information that the attacker can learn about the internal structure of the web application, the database's names, fields, maybe the IP address of the database, and it can create a great enumeration process for the hacker, because it enables to learn stuff about the network. But they are also a great platform to create reflected cross-site scripting attacks, because usually if I send some text to be processed on the server side, and the server side returns an error page, in many cases it will also demonstrate and print the text that we've sent in our request. So this is also a platform for an attacker to create cross-site scripting. So if using automation, we will find error pages, and this asset, you will the penetration tester will see that the text that was sent to the server is reflected back in the error page. Boom! Using automation, you have discovered a cross-site scripting vulnerability in the web application. So how far can we stretch the attackable assets concept? I talk about detection of supporting technologies, forms, error pages, great stuff. Deliver from my experience a lot of goods during the automation process of the web of validation. But can we create, some more types of assets, like command injection path asset, file upload asset, paths and assets which will enable deserialization attacks, or as I mentioned before, cross-site scripting attacks, file inclusion assets, SQL injection assets. The answer to all of those is yes, okay? So using automation, maybe you won't be able to find all of the SQL injection assets. Maybe you won't be able to find all the deserialization types that exist in a web application, but the automation will be able quickly to give you something from those fields. And if it finds something, great, then the manual penetration tester can search for more exotic things. But we in Pentera make our platform so complex that we always try to find more and more and more assets. So let's talk about the web fuzzing algorithm. The web fuzzing algorithm basically looks in the following manner. We're asking from the agent, please give me a route and parameters that were discovered in phase number 1. The engine transmits, okay, so here you have a path. This path is a post request, and here are the parameters, ID, name, street address, etc. The engine will send to the web application a post request to that path, and the parameters will have a specialized input. Specialized input is it's an input that will help to disclose a specific type, a specific family of attacks. For example, for cross-site scripting, we will have specialized input. For SQL injections, we will have another form of input. So we send this input to the web app. We get a response from the web application, and we verify if the response is attack valuable. Attack valuable, it means that using parsing of the response, we can derive an asset, okay? And if the page is vulnerable to a family of attacks using the specialized input, we will save the URL and the parameters that gave us this effect. And of course, in every attack engagement, in every penetration testing engagement, you want also to deliver a proof. So once we are familiar with the vulnerable web route and the special payload that gives us enables us the attack, it will generate a proof collection payload, and this proof collection payload will be sent to the web app, and usually will bring some artifact from the application that says, here's a proof that you are vulnerable to deserialization attacks. Here's a proof that you are vulnerable to cross-site scripting. Okay. So let's talk about an example for cross-site scripting. In cross-site scripting is when the attacker understands that there is a URL, there's a parameter that when is requested, the returned material from the web server executes code on the legitimate user's browser, and this code can do many stuff. One of them is collecting data, collecting cookies. So the reflected XSS looks that an attacker will send usually a phishing email with a link to the user. The user will request that link from the website. And because the website and the link is poisoned with a reflected XSS cross-site script, the returned answer will execute code on the user's browser and allow for the attacker to steal data from the user. So the specialized input will be closing brackets, opening new brackets with some gibberish, and then closing brackets will also contain gibberish. And by the name of the attack reflected, if we send in one of the parameters the specialized input, if we get in return from the website, we get the same text that we send in our request, this means that the website reflects the data that we send to it. And reflection of data means that we can create some payload, not just the ABCD tags. We can put in instead a JavaScript payload. So this basically allows us this very easy method of iterating on all routes, sending the specialized input. And if one of the routes returns the same string, means that the given route is vulnerable to reflected cross-site scripting. Great. This is a reflected cross-site scripting asset, allows code execution on the browser. ASP deserialization attacks examples. You send a stream of bytes to the web server. It is translated to the ASP.NET object, and the ASP.NET engine interacts with it. Interaction with a wrong piece of data can create code execution if not properly handled. So in this case, there's no need for specialized input. Just by accessing all of the possible routes, and if one of the routes returns a view state string with value and quotes, this allows us to inject a .NET object. A .NET object will be deserialized and may be executed on the web server, which will allow for code execution. In Pentera, we fully utilize this automation model, not just for web application, but for other forms of other areas in hacking, domain, network, infrastructure. But in the last versions of Pentera, we implemented this as well. And Pentera collects assets. It executes attacks using those assets, and the attack execution derives more and more and more possible attack assets. And this is something that is continuous. Each discovered asset generates a new form of attack. So on the upper left side, you can see, I don't know if you can see, but there's remote file inclusion vulnerability, which propagates into code execution. The code execution basically evolves into compromise and code execution on the operating system, and allows privilege escalation and creation of backdoor user, for example. You can see on the bottom right side, you can see example for local file inclusion. You see the path, and you can dump the shadow files, for example. Shadow files can be sent off to cracking, and you can start with web attacks, and you will find yourself moving into other areas of attacks like password cracking, which are not basically related to web, but everything is in one ecosystem that lives together. And a breach this shows how a breach in web application can create a full compromise of the web server, and maybe even enable lateral movement. So to summarize, I bet you are all agreed that web applications are important to validate their security because of the potential impact, and because of the fact that there are so many of them on the network. Mapping the possible routes using proxy server will enable a quick generation of attackable assets, and all is done with simple textual analysis. Each attackable asset allows straightforward identification of low-hanging fruits and weaknesses, weak authentication, known vulnerabilities in supporting technologies, deserialization attacks, reflected cross-site scripting, and more. It's very important to create automation for common issues discovery, because it improves the effectiveness of the penetration testing engagement, and allows to get results quicker. Thank you very much for listening, and enjoy the rest of the Exposure virtual event.